Chapter 3, Applications of Differentiation. Chapter 3.3, Curve Sketching, Asymptotes, and Rational Functions. This focus on finding the asymptotes of a graph and limits involving infinity, graph of rational functions. Rational function is a function f that can be described in terms of a quotient of two functions. And the domain of f is all those points that that q of x is not equal to 0. A vertical asymptote is where as x from the left goes to infinity, from the right it goes to a positive infinity, or from the left it goes to a negative infinity, or from the right it goes to a negative infinity. If the graph of a rational function never crosses a vertical asymptote, that's important. If the expression that defines the rational function is simplified, meaning it has no common factor other than -1 or 1, then if a is an input that makes the denominator 0, then x equal to a is a vertical asymptote. Here's an example here. You can simplify it so the only common factor between the numerator and denominator is going to be a 1 or a -1. And then those values in the denominator that make equal to 0 are vertical asymptotes. In this case here, x equal to 1 and x equal to -1 are vertical asymptotes. So let's look at a graph of it. Here's a graph of it here. And you can see here what happens to x as it gets close to -1. It blows up. It blows up. Okay. When it approaches +1, it blows up. So you can see it has vertical asymptotes there. Okay. Now we look at this graph here. Okay, there's a graph of this function here. And this one here, they factor it out, and nothing cancels out. So it has vertical asymptotes at 0, 4, and -4. And it'll behave in similar fraction, except it'll be 3 places where it has asymptotes. This one has 2, at 1 and -1. Horizontal asymptote, if the following true, as x approaches goes to -infinity, gets larger negatively, f of x, the output approaches a particular value. And if it approaches x gets larger infinitely, the output goes to a particular set value. Then it has a horizontal or vertical, horizontal asymptote. Horizontal asymptotes, the graph of a rational function may or may not cross a horizontal asymptote. Horizontal asymptotes occur when the degree of the numerator is less than or equal to the degree of the denominator. The degree of the polynomial in one variable is the highest power of that variable. So then he has to determine the horizontal asymptote so that it divide by the highest power in that particular function, which happens to be x squared. So divide everything by x squared. Okay. Then you take the limit as it goes to a -infinity. It goes to 3/2. So 2 over x goes to 0. 4 over x squared, as x gets incredibly large, it goes to 0. Gets closer and closer to 0. The larger and larger, or more negative or more positive it gets close to 0. So in this case here, the horizontal asymptote is at 3/2. Okay. So in this case here, to give it to an expanded form, so you multiply it out, Okay, then you to find the horizontal asymptote, go ahead and divide by the highest power of x. You see that the horizontal asymptote here, let it go, take the limit as it goes to 0, you end up with 2/15. Let's see here. Now, hold on for a second. Let's see if I can graph this thing. See what happens. Okay, let's see what happens if I graph this one. There. So according to this here, we have a horizontal asymptote at 2/15. So if I zoom in here, I should see that it doesn't cross that point, the y equal to 2/15. So let's zoom in. Okay, you can see right there it doesn't cross that line. Now notice it says here also that, going back, the graph of a rational function may or may not cross a horizontal asymptote. So you can see there in this case at 2/15, there it doesn't cross, but this line here does cross. So it has a horizontal asymptote at 2/15. Okay. This one here, they asked you to sketch the graph. All I'm interested in is finding the asymptotes. Why is that important, knowing the asymptotes? Well, in the old days with computer programming, you want to be, when you're doing your programming, you want to be sure that you have a good function, that it doesn't blow up when certain values are put in, inputs are given to it. So you would have to have a workaround, another program, in case it is equal to 2, or in case it is equal x is -2, so the program doesn't fail. So you want to know that stuff ahead of time, because you don't want to be on a launch pad and have something happen, or be out in space and have something happen and you can't figure out what to do and the whole thing shuts down. That's why it's important to know something about asymptotes. Yeah. Okay. Now for this one here, let's just put this in the calculator and see how it turns out. So I have 8 divided by is it x squared? Yeah. Minus 4. Okay, let's see how this graph looks. And let me zoom out. So it looks like we have asymptotes. According to that, we're going to have asymptotes at x equal to 2 and negative 2. So when x is 2 or negative 2 is going to be an asymptote. So let's go ahead and zoom out and see what it looks like. Here's another one here. We do have a x equal to 2 and negative 2. There are vertical asymptotes. And so the horizontal asymptotes, notice it says there the degree of the numerator is less than the degree of the denominator. So the x-axis is the horizontal asymptote. And notice in this case here, it doesn't cross the line of y equal to x equals 0. It doesn't cross the line of y equal to x. So in this case, it doesn't cross the asymptote. That's why it says in there it may or may not cross the asymptote.